I hope you are doing well. In this video, we'll look at sets of numbers. Like so, there are a lot of symbols used to denote sets of numbers. We have a lot of sets of numbers as well as the symbols used to denote such sets of numbers. And the first set of numbers which we'll talk about, we have natural numbers. So for natural numbers, these are simply positive integers. So the natural numbers are counting numbers starting from 1, 2, 3, and so on. Such numbers are natural numbers. Counting numbers from 1 to infinity, these are natural numbers. Then the symbol for natural numbers, just using capital letter N like that. That's the symbol for natural numbers. Then number 2 is talk about integers. Okay, so these integers include the negative and the positive numbers, including 0 itself. So these positive and negative numbers are the ones we call integers. So we exclude the fractions. All the fractions are excluded under integers. Fractions and decimals are not included under the integers. So we use capital letter Z representing integers. So the counting numbers from the negative, positives, these are the ones we are calling integers. Don't just include fractions as well as decimals. Okay, from there we can talk about another set of numbers, the rational numbers. Rational numbers. So rational numbers are represented by simply capital letter Q like that. Those are rational numbers. So rational numbers by definition are simply numbers that can be expressed in the form A over B, where A and B are integers and that B shouldn't be equal to 0. Otherwise, we can't have a fraction where the value of B there, which is the denominator, being equal to 0, then that will be undefined. So that those are rational numbers, numbers that can be expressed in the form A over B, where A and B are integers and that B shouldn't be equal to 0. Then we have real numbers. So real numbers include all rational and irrational numbers. The real numbers include all rational and irrational numbers. Since for irrational numbers, we can't express them in the form A over B. So real numbers include rational and irrational numbers. Rational and irrational numbers, these are real numbers. So for irrational numbers, this is the opposite of rational numbers. We can't just express them in the form A over B. And for irrational numbers, we use the symbol Q prime like that. That's the symbol for irrational numbers, Q prime. Then we also have complex numbers. So the complex numbers symbol we have C. Okay, so the complex numbers, we can actually say these are imaginary numbers, numbers like 2i, numbers like 3i, those are the complex numbers. I itself, these are complex numbers. So we'll talk more about the complex numbers later. Okay. So from these numbers, let's start with the rational numbers. So rational numbers, we have already said they can be written in the form a over b, where a and b are integers and b shouldn't be equal to 0. These are the rational numbers. And before we go any further, let's understand the decimal numbers. Before we go any further, let's understand decimal numbers. Okay, so these decimal numbers can be grouped into 3 categories. The first one are called terminating. We have terminating decimals. So the terminating decimals, we should know that they belong to rational numbers. Terminating decimals belong to rational numbers. Examples of terminating decimals, we can have numbers like 0.3, 2.34, 0.234. As long as it is a decimal number and we are able to tell what the last number is, then that is terminating. 0.3, we know the last number is 3. After decimal point, 2.34, last number 4. These are called terminating decimals. You know what the last number is. It's not a number like 0.3, then you just have 3, and so on. No. As long as you know what the last number is, these are called terminating decimals and belong to a group of rational numbers. Okay, let's talk about the other group of decimal numbers. So the other group of decimal numbers, we are saying repeating decimals but not terminating. So we can have repeating decimals which are not terminating. For example, if you have 0.3333 and so on. Another example, let's say we have 1.171717 and so on. Then let's another example, 6.1565656 and so on. These are called repeating decimals but not terminating. They are repeating decimals but we can't tell what the last digit is. These are non-terminating. So these also belong to rational numbers. Also these are rational numbers. Okay, so by repeating decimals, we simply mean that if it's 3 is being repeated several times, and this one actually can be shortened to 0.3 and a bar on top there, meaning that 3 is being repeated several times. Even this one can be shortened. You can say 1 point. What is being repeated? We have 17 with a bar on top like that. 17, showing that 17 is being repeated. Even in that one, we have 56 being repeated. So we can write as 6.156. So on top of 56, we have a bar like that, meaning these are being repeated. So such decimal numbers are so called rational numbers. And the last group of these decimal numbers are saying non-repeating decimals. So non-repeating decimals belong to irrational numbers. For example, if you have a number like 0.276314583 and so on. So if you check this number, there is no any specific pattern that is formed. Unlike compared to those numbers, we have 171717, but for these we have 27, 63, 14, just like that. There's no specific pattern that is formed. You can have another one, maybe 0.124866132, just like that. There's no any specific pattern that is formed when the numbers after the decimal point, no specific pattern is formed. So these are called non-repeating decimals. Hence, these are irrational numbers. Okay, so these are the three sets of decimal numbers. And to which group do they belong? Are they irrational or irrational? Hope you have gotten the concept. Okay, so we should know how to convert these repeating decimals, which are not terminating the rational numbers. We should know how to convert them in the form of A over B. Okay, so we know that if you have been given, let's say 0.1, the first one, let's say 0.1, second, let's say we have been given 0.25, like that. Then convert these decimals into fractions. You know that for 0.1 there, it is simply 1 over what? It will be 1 over 10. Direct like that. Then for this one, it will simply be what? It's 25 over 100 over 100. And 25 into 25, that's 1 over into 100, that's 4. So for those ones, it's easy, right? Then what if you have something like 0.333 being repeated? We have 333 being repeated. How can we convert it to the form A over B? We write it in form of a fraction, from a decimal number to fraction, like that. So we should know how to do that. And to that, let me just get these questions. We'll look at the examples. Now we can convert such numbers. Okay, so we have questions there. Express each of the repeating decimals below in the form A over B, where A and B are integers and B is not equal to 0. So we have those 4 questions. We should do write them in the form A over B such that B shouldn't be equal to 0. Okay, so this side I'll write solution. The first one, A, we have been given 0.3 and a bar on top. So if you have 0.3 and a bar on top there, what does it mean? Simply means that 0.3 is, 0.3 is being repeated several times. So we just have 0.33333 and so on. It's being repeated several times. Now how can we convert 0.3 to form A over B? So it should be converted to the form A over B as a fraction. So to do that, just pay attention. So the first thing, you get what you have been given. You say let x be equals to 0.3 and a bar on top there. That's the first thing. Then from there you check, is the decimal point immediately before repeating numbers? So the decimal point is immediately before repeating numbers. Then after that, the next thing which you should do, you multiply this equation 1, so you can multiply it by 10, 100, 1000 and so on. So our aim is that this point should come after the repeating number. So it should come after the first repeating number. So the first repeating number, it's 3 there. So this point should go somewhere there, like the way we have this point should be moved to there. So what should we do? We should just multiply equation 1 by what? 10. So say multiply 1 by 10. So we multiply equation 1 by 10. So we multiply from both sides. So we have 10x being equal to, this side you multiply it by 10, meaning that point will move there. So we have 3.3, like that. And this is the second equation. Okay, then the next step, you should subtract these two equations now. So you say subtract equation. So at this point you simply say you are subtracting its equation what? 2 minus equation 1. You subtract the two equations. So from the left side you have 10x minus x there, which should be equal to, so we have 3.3 minus 0.3. So 10x minus x, that's simply 9x, being equal to 3.3 minus 0.3. So that's 3 which is terminating would disappear, will just remain with 3. Then we divide by 9, will remain with what? X equals to 1 over 3. So we have written 0.333 and so on in the form a over b, which is 1 over 3. We have converted it back to a fraction. So let's solve another question so that things can even make more sense. Okay, so for b there, b, we have 0.13 there. Okay, so for this one, it's just 3 that is being repeated. So to write this one, it can actually be written as 0.1333. So it's just the 3 which is being repeated several times, has been just shortened to that. So the first step, you let x be equals to what you have been given, 0.13. That's what you have been given. Then check. So this is equation 1. Before you even go any further, just check, is the decimal point immediately before repeating numbers like this one? It's not immediately before repeating numbers. So just make sure it's immediately before repeating numbers. The repeating number is 3. So what do you do to shift the decimal point from there to there in between 1 and 3? You multiply equation 1 by 10 so that the decimal point can move by 1 place to the right. So we'll say multiply 1 by 10. So multiply equation 1 by 10. So I have 10x being equal to, this will give us 1.3 and a bar there, meaning it's being repeated. So that's the first thing you do. Then the second thing, you should make sure that this decimal point now is moved behind what? The first repeating number. So the first repeating number is 3. So just make sure it's behind there. That's the first thing you do. So you should multiply by what so that this decimal point goes there. Of course, it's 10. So you should multiply this equation by 10 again. So we'll multiply 2 by 10. So this will be 10 times 10 there to be 100x being equal to 1.3. Remember for this one we have 1.333. 3's are being repeated. So 1.3 and so on being multiplied by 10, we expect to have 13. So this decimal point will move to go there. 13.3 since 3's are being repeated and a bar on top. So this will be the third equation. After that, just subtract these two equations. So say it's equation 3 minus equation 2. So for equation 3 we have 100x minus 10x, which should be equal to, that's 13.3, and the bar there, minus 1.3, the bar there. So this will be 90x being equal to 13.3 minus 1.3 to give us, that's 12. So divide by 90 over 90. Therefore, x will be equals to, so 12 over 90, simplifying this one, will end up having 2 over 15. So that's it. Let's solve another question, that's B. Then for C, we have been given, so that is 6.156 and a bar on top. So for this one, what is being repeated? We have 5656. So this one actually can be written as what? 6.1565656 and so on. So 5656 being repeated. So first step again, you let x be equal to what you have been given, 6.156, and the bar on top, your first equation. Then check, is the decimal point immediately before repeating numbers? So what are these repeating numbers? 5, 6, 5, 6 there. So this decimal point should be immediately before repeating numbers. So the right place for the decimal point is there, immediately before repeating numbers. That's what you do, should come immediately before repeating numbers. So to move this decimal point one step in front, you simply multiply it by 10. So multiply equation 1 by 10. So this will be 10x being equal to give us what? 61.56. This decimal point has moved one step. That's it. The first thing. Second equation. Then to form the third equation, make sure that this decimal point now should come immediately after the first repeating numbers. So the first repeating number is 5, 6, 5, 6. So this decimal point should come there, behind the decimal, the first repeated numbers. So what should we do to this equation? So that this decimal point moves 1, 2 steps in front. Should multiply it by 10, rather by 100, so that it will move 1, 2. So multiply 2 by 100, so that we have 1000 x this side being equal to, so multiplying by 100, the decimal point to move 2 steps. We have 6, 1, 5, 6, then point there. Remember 5, 6 is being repeated, so we still have 5, 6 this side. And this will be our third equation, like that. Okay, then here, let's now subtract these two equations, equation 3 and equation 2. So the equations to subtract, for equation 2, we have a decimal point immediately before repeating numbers, and this decimal point immediately after the first repeating numbers. So these are the two equations you subtract. So we'll say we are subtracting equation what? So it's equation 3 minus equation 2. So subtracting the two equations, we have 1000x minus 10x being equal to, we get 6156.56 minus, that's 61.56. Subtract the 2. So this side 1000 minus 10, that's 990. X being equal to, then when you do your calculations this side, you will find 6095, like that. Then we should just divide by 990 over 990. So x will be equal to 6095 over 990. Then reducing this one further, we can have 1219 over 198. So we have converted 6.15, 6 being repeated 5656. They form A over B, which is 1219 over 198. So these are the steps you should follow. Okay. Then the last question, we have that one, 1.171717 being repeated. So you can try that one. You can pause the video, try it, then you get back just to see if you have gotten the concept. Okay. So we have 1.171717. That one being repeated. So what is being repeated here? 171717 being repeated several times. So what should we do? We should represent this one using a bar first. So it's 1.17 and a bar on top, 1.17. Then you select x be equal to 1.17, like that. Then this is equation 1. So check your equation 1. Is the decimal point immediately before the repeating numbers? Yes, the decimal point is immediately before the repeating numbers. Unlike this one, the way it was. If you check this one, the decimal, this is the repeating number, but there is also this one, which is coming before the repeating number. So no wonder we had to multiply this by 10, so that this decimal point comes immediately before the repeating number. After that, you then multiply it by another 10, so that the decimal point comes after the repeating number. Okay. So for this one, you can say equation 1 is just, okay, since this decimal point is immediately before the repeating numbers 1717. So the next thing we should do, should make sure the decimal point is after the repeating numbers. So it should come there. Should be after the repeating numbers. Should move from there to there. That's what we do. That's our aim. Okay. So what do we do? How can we make the decimal point move twice in front? We multiply it by 100, so that it moves 2 steps. So we multiply equation 1 by 100. So it will be 100x being equal to, so it will be 117.17, like that. Okay. So we have made sure that the point is after the first repeating numbers. Then we can say this is equation 2, actually. So for the first equation, decimal point immediately before repeating numbers. For the second equation, decimal point immediately after repeating numbers. So we just subtract these two equations. No need to even come up with equation 3. So we'll say equation 2 minus equation 1. This will be equal to, so for equation 2 we have 100x minus x being equal to, that's 117.17 minus 1.17. So this side you get 99x being equal to, then we have 116. Then we divide it by 99 over 99. Therefore x will be 116 over 99. So that's how you convert these repeating decimal numbers into fractions. So I hope you have gotten the concept. Otherwise, you can just go through again, rewatch the video, and you'll be able to get the concept clearly. Okay. So that's it for this video. I hope you have understood. See you in the next lesson.